All right, so yet again, I did not put audio onto my video. I love when I do that. So here it is. I am talking about the different types of chemical reactions, and there is 5. The combination reaction, sometimes we also call that a synthesis reaction, as in you're synthesizing chemicals or you're making chemicals. And we'll go into each of these in more detail. This is supposed to say decomposition. Instead it says decombination. My apologies. Didn't catch that one. Okay, so that's the second one. Then we have single replacement, double replacement, and combustion. So like I said, we're going to go into each of these individually in a moment. I think I'm talking about here how combustion is the same thing as like a combustion engine, which is what you have in your cars, right? It's the explosion. So here we have a synthesis reaction, and in your note sheet, it asks you to write the AB equation and to give an example. So for the written part, for synthesis, right, to synthesize means to make, and sometimes we call this a combination reaction as well. So it's where you take 2 or more substances and react to form a single new substance. So that, where I underlined, right, that's sort of what you want to put in your definition of the reaction, right? 2 or more substances react to form a new substance, one new substance. And that's represented with our AB diagram right here. And you do need to type that in to the other column, right? So you take one thing and plus 2, and then you're going to make one single product, right? So you're adding things together to make one single product. There's another example of it over here with the A and B colored circles. And then down here we have a real life example where you would take sodium plus chlorine, right? Sodium plus chlorine, and you would make sodium chloride. Okay, I think I'm gonna get there. Okay, sodium chloride, right? So you're taking 2 separate things, adding them together to make one product. You take 2 things, make it into one. That is our synthesis reaction. Okay, next we have our decomposition reaction. This is the same thing as if you were to say to decompose, right? So to decompose means to like break down. Think about decomposing, I don't know, dead things. They're breaking down. So it's basically the opposite of a synthesis reaction, right? So you're taking a single compound. I'm gonna get there. I am. A single compound, and you're breaking it down into 2 or more products, right? So our AB diagram, you start with one thing, and you're breaking that down into its 2 separate parts, right? And again, here, the A and B can represent any chemical, right? They're just sort of like X. A and B can represent any chemical. So our example here is our copper chloride, or CuCl2, and that will break down into Cu and Cl2, right? So you're taking one thing, you're breaking it down into 2 separate things. I can't do the little subscript 2, so I'm just typing in a normal 2. Love that. So that is our decomposition. It's just basically the opposite of a synthesis reaction. Okay, so now we're going to start a little bit more complicated with the single replacement reaction, right? And in the single replacement reaction, you are going to have one element that replaces a second element in the compound, right? So one element is replacing, just like it sounds like, right? So here we have A plus BC, and we have 1 plus 2, 3 is together, right? And that turns into 2 plus 1, 3. If that sort of helps explain it. So in other words, you've swapped out A and B, right? You've exchanged A for B in that compound. And there are a couple different examples of that. Over on the side, maybe, hopefully, I will get there. Yes, okay. So this is going to become HCl, hopefully. right? The products for this, we're going to exchange Na. So this is going to become HCl plus Na, right? So we've swapped hydrogen and sodium, right? It's a single replacement. You're starting with 1, 2, 3, and you're ending with 2, 1, 3, right? And the same thing is happening in the second example. And you're going to swap out, so it becomes KCl and sodium again. Notice that you're keeping the metals. You're not going to put two metals together, right? Sodium and potassium are both metals, right? So they're both, they're the ones that are doing the exchanging. You're not going to see NaK. And again, predicting these products we haven't gotten to yet, and we will learn how to do that. Don't worry too much about it right now. You just need to be able to recognize what kind of reaction is happening for the homework today. You just need to recognize what type of reaction, right? So you can see there that we've had an exchange, right? A replacement. Yeah, so you're not going to see NaK, right? Because that's two metals together. You're not going to see that in a single replacement reaction. Okay, next up is our double replacement reaction. Again, this one is a little bit more complicated, but it is just what it sounds like, right? So you're exchanging, basically you're doing a double replacement, right? So you're swapping, I'm going to write this in, aren't I? Okay, you're going to swap two elements. Right? That's a sort of simpler way to write it. And we will, and that includes polyatomic ions. So if you remember those polyatomic ions from our naming unit, those count as like an element or a piece, right? So in our first example, we have NaS, right? So we'll write that NaS and CdNO3, and that NO3, this is important because it's in the parentheses, you know it's a polyatomic ion, right? It's going to act as one unit. So we have 1, 2, 3, and 4, and you're going to swap two things, right? You're just exchanging them. So we turn that into 3, 2, 1, oh, that was ugly. 1, 4, right? So you can see we've swapped those elements, and we still keep NO3 as one unit because it is a polyatomic ion. We know that it's in the parentheses. There's also lists on the internet if you want, or in your notes, of polyatomic ions. And we can see there's some other examples of that as well, right? You're taking 1 and 2, 3, 4, and you're swapping those twice. So here we have our AB diagram. Right, so it's ABCD turns into ADCB, and again, the ABCD just represents any element or any polyatomic ion, right? So you can see all the examples of that, and they will match up. Finally, we have the combustion reaction. This is one of the easiest to recognize. Unlike the other reactions where it can be any element or any compound, right? This is always the exact same reactants and the same products. And combustion reaction is what you think of when you think of explosions, right? So basically, a combustion reaction is where you take a hydrocarbon, which is CNH, plus oxygen, equals carbon dioxide and water, and that will always be the same, right? So over here we have a hydrocarbon. I'm going to go to the example, right? Maybe I'll get there. So that's sort of your AB diagram for this one, right? So you have your hydrocarbon. Notice that it's C8H18. That can be anything. It can be C2H4. It can be C16H326. You know, it doesn't matter what those numbers are. It just matters that there's a C and an H together. So a hydrocarbon, and then you have your O2, and that turns into your CO2 and your H2O. And notice that the coefficients, right, to balance that equation might be very different, but the actual compounds, the reactants, and the products will always be the same, right? So you have that CH, it can be, like I'm saying down here, it can be C4, H6, it can be C18, H36, it doesn't matter as long as you have that CH. And then everything else will be the same, CH plus O, oxygen, turns into carbon dioxide and water, right? So that is your AB diagram for this one. We have an example right there. And sort of to define it, we want to remember it produces energy in the form of heat or light. So this is what you think of. Fireworks are combustion reactions. Any explosion is a combustion reaction. Anything that causes fire is a combustion reaction. This is also what runs your car engines. They're combustion engines that produces the energy to drive your cars, right? And engines and stuff like that. Okay, so again, to review, we have these 5 different types: a combination, where you just combine things or synthesize a product; decomposition, the opposite, where you break things down; single replacement, right? You're swapping one out; double replacement, you're swapping 2 out; and combustion, which is that really specific reaction, right, that produces light and energy. And I'm just walking through this a little bit slower than I spoke, but that's okay. This is just a quick review. So all you're doing in today's worksheet is identifying the type of reaction, right? That's all you have to do. We will work later on the next lesson on how to predict the products of these reactions and then balance them. But for now, we are just identifying them in the worksheet, right? So that's all you have to worry about, is being able to tell what type of reaction it is. Okay, and I think that is about it. Yeah. We will just wait so the audio matches the video.